Hello friends, welcome to the course Essentials of Data Science with R Software 2, where we are trying to understand the topics of sampling theory and linear regression analysis. In this module, we are going to continue with the sampling theory with R software, and we are going to continue with the chapter Stratified random sampling with R software. So you can recall that up to now we have developed the theory part of stratified random sampling. Now the next question is how to implement those things on the R software. So as you have seen in the case of simple random sampling also, when the role of software like R comes into picture, then R is helping us in drawing the suitable sample. And after that, we have to write a small function to find out what we aim to find. Similar is the story in the case of stratified sampling also. At least to the best of my knowledge, I could find 3 possible packages which are helping in drawing the sample from a stratified random sampling setup. And those packages are sampling, strata and survey. And means all those packages are more or less similar. The only thing is this: they have got different types of commands, different types of options. So as far as this sampling and strata are concerned, they basically help us in drawing the sample only. Once we draw the sample, then we can carry forward our computations further. But this package survey has one more advantage, that it gives us the standard error as well as the estimate of population mean. So I will try to give you the details of these 3 packages, and among these 3 packages I will be giving you more details on the package sampling. And once you understand the sampling package, how to execute it and how to draw the samples, I will try to give you a quick overview of the packages say strata and survey. Right. So that is our plan, and this is how we try to proceed. So first I will try to show you the slides, and then I will come to the R software and I will try to execute those commands which I will teach you. Okay. So right. So in order to use the package sampling, we first need to install it and load it on our computer. So in order to install the packages, we have to use the command install.packages, and within the double quotes inside the parenthesis we have to write sampling. And once you install it, then you can load it by the command library. One of the conditions and restrictions in this package is that the data has to be in the format of data frame or matrix or a tabular, that is data.table format. Now from this package we have to draw the samples, and in order to draw the samples I am going to use here a function which is named as stratified.r. This is a script, this is a function which has been written, and means I would say make it clear that I have not written this package, but this package is available in the GitHub. GitHub is a depository, that is a website, and actually this is a work of someone whose login is MRDWAB, and this script is available at this address, and I would like to express my acknowledgement for this person who has developed this program to draw the sample. And you will see that this is a pretty simple program, and it is very easy to handle. So, if you follow my slides to draw the stratified random sample, first you need to have this function stratified.r on your computer. So, what I have done that here in my slide I am giving you this address, and this program stratified.r is there, and you simply have to copy this address from here and paste it in any web browser, and this program you can download, or you can also copy from there and paste it in the R console. I also have uploaded this program on my personal website just for the sake of convenience, so you can also copy and paste this program from here also, right. And you have to download this program and you have to save it in the working directory in which all your programs are stored, or all the files are stored when you try to work on the R software. So, just to show you here how it is going to work, means I can copy this address over here and I come to here web browser and I try to paste it here. You can see here this is the program which is here. So, you can simply copy it, or if you want to see from this site also, I can copy means another address just to show you. You can see here this is here, right. So, you can simply just copy from here and just simply paste it into your R console. That is what I want. And just for your better understanding, I have copied this program here also. So, you can also copy it from my slide and you can proceed forward, and here I am giving you a screenshot that how it is uploaded on my website. And once you have this program on your computer and you have uploaded it on your R console, then we have to use stratified function to sample from the given data frame or a given data table. Right. Now, the question is this, how are you going to sample because the data frame will have different columns. For example, a data set may look like that there are different variables which are arranged in different columns. So, first you need to specify that which is your grouping variable, or which is the variable which you are going to use for stratification. So, one or more columns in this data frame is to be used as a stratification or grouping variable, and then the command to draw the sample is given here. You have to write down stratified, and after that there are several options like as INDT, group, size, select, replace, keep, both sets, etc. So, I will try to give you a brief idea that what is the role of these options, right. This value here INDT, this is the input data. Here you have to specify that what is your data frame or data table from where you want to draw the samples. Then there is another option here, group. This group is actually column which has to be used to create the groups. So, this can be a character vector of column names or a numeric vector of some column positions. Actually, if we are using more than one variable to create our strata, then we should list them in the order of slowest varying to the quickest varying. So, this can be a vector of names or column indexes, right. Then there is an option here, size. So, this is the desired sample size. So, here in this package there are two options that we can draw the samples by equal allocation or by proportional allocation. So, if I try to give the value of size between 0 and 1 and say expressed as a decimal, then the size is set up to the proportional allocation. For example, if I say size is equal to 0.2, say size is equal to 0.2, so that is indicating that we have to draw 20% of the sample from every strata. So, this is essentially your proportional allocation. And if you try to give this size as a single positive integers, for example, I can say here size is equal to here 10, then it will indicate the equal allocation, and this will indicate that we want to have the same number of sample from each of the group, that is each of the stratum. And similarly, if size is a named vector, then the function will actually check to see whether the length of the vector matches the number of groups and the names matches the group names. Right. Okay. Now, after this, there is another option here, select. So, this select is a list which contains the label from the group variable in which we are interested, and this list name must be presented as a variable name for the input data set. Then we have an option here, replace. So, it will indicate that whether we want to draw the sample by SRS-WOR or SRS-WR, that is without replacement or with replacement, and this is a logical option. That means it will take two possible value, true or false. And similarly, there is another option here, keep row name. This is also a logical variable. So, this will take two possible values, true or false. And usually what happens that if the input is coming from a data frame or a matrix or a data table, then usually the row names are dropped. But if you want to keep the row names, then we have to use this option. Rather, I will take here a simple example to show you that the things are pretty simple and how these things can be used. Similarly, there is other option both set, but I will request you that you please go to the help menu and try to see all these options before you move forward. So, here you can see here I have copied and pasted this program on my R console. Yeah, I will try to show you on the when I try to execute it, but you can see here this is how it will look like. You simply have to just copy the entire program and just paste it on your R console, right. Okay, and this is the screenshot. So, after you have pasted it correctly. Okay, now I do. So, now in order to explain you, I have artificially created a data frame of 6 columns. So, this data frame is created in the following way, that the first column is a variable capital ID, which has number from 1 to 50. Then in the second column I have taken a variable here A, in which I have chosen 5 names of the cities, Lucknow, Kanpur, Delhi, Mumbai and Kolkata. And from these 5 cities we try to draw a sample of size 50 by SRS-WR. So, that means we have 50 observations on A. Similarly, I try to choose the second variable B. In the column B, there are 50 values starting from 101, 1022 up to 150. And similarly, in the next column, we have a variable here C, which is taking the value from 201, 2022 to 50. And then the next variable is here D. D consists of 3 values: average salary is equal to 50, average salary is equal to 75 and average salary is equal to 95. This average salary is indicated by AVSAL, and from these 3 values we try to draw a sample of size 50 by SRS-WR, right. And then similarly, I try to take the last column E of 2 values, say male and female, which are indicated by M and F, and I try to take a sample of 50 observations by SRS-WR. So, you can see here means I have taken these many variables, and on each of the variable I am trying to take 50 observation, because in the data frame, the condition is that every column should have the equal number of observation. And when I try to create this data set over here, you can see this will look like this. This is a screenshot which is here ID, then here variable A, variable B, variable C, variable D and variable E. Right, definitely I am not executing this data set at this moment, because you can see here I am using the command sample here, sample here, sample here, sample here. So, when I try to draw the sample by simple random sampling with replacement, my data will be different than the sample which I have represented here. So, my data frame will also be different than this data frame, but now I am taking this data frame as fixed quantity. Now, suppose we aim to obtain 10% sample from all the variable A groups in the data frame D81. This data frame with what I have created here, this has been stored under the name D81, data 1. Okay. So, now from this population, now I try to take here a sample, and I am using here this variable here A, which is the name of the cities, as my grouping variable. That means I want to select the sample on the basis of this here A, and the corresponding values will be chosen accordingly. What does this mean? For example, if you try to see here, if suppose if this value is collected, say daily, then all these corresponding values will also be selected in the sample. Actually, that is the advantage of using this stratified function, that it gives you lots of liberty. So, when I am saying that I want to have 10% sample, that is proportional allocation, that means I have to use here the numbers of size between 0 and 1 followed by a decimal. So, 10% can be represented as 0.1. So, my command becomes here stratified, then the name of the data frame, then the name of the variable with respect to which we want to sample, and the size of the sample. In terms of proportional allocation, you have to give the number between 0 and 1. Okay. So, you can see here, this is what I get when I try to execute it on the R console. Right. So, you can see here, this is my here variable A, and so these are the sample sizes which have been collected. So, there are 2 samples from the Delhi, and 1, 2 sample from the Kanpur, 1 from Calcutta, 2 from Lucknow and 1 from Mumbai. Right. So, remember that A also has been chosen randomly. So, next time if you try to repeat it, this column will not remain the same possibly. And once you try to look at this structure, now there are 2 Delhis and there are more number of Delhis in the data frame. So, now this row is giving the other part of information, that this Delhi is coming from the ID number 7. That means here we have here ID number here 7 if you try to see, and this unit is coming in my sample. And similarly, the ID corresponding to 48, 11, 36, 10, etc., they are coming in my sample, and the corresponding values of the variable B are listed here, corresponding value of C are listed here, and the corresponding value of D are listed here, and corresponding value of E are listed here. Right. And here it is giving you the probability of different collections, and it is here mentioning that to which stratum these units belong to. So, you can see here I have taken here 5 cities: Delhi, Kanpur, Kolkata, Mumbai and Lucknow. And so, this program has automatically created the strata also. It has given Delhi strata number 1, Kanpur strata number 2. This is clear from here if you try to see. Okay, I will use a different pen. So, if you try to see here 2, this is here Kanpur 2. So, you can see here it has given the Kanpur's means all the Kanpur names have been grouped in the stratum number 2, and similarly here all the cities under the name Delhi, they have been grouped under the stratum number 1. Kolkata has been classified into stratum number 3, Lucknow has been classified into stratum number here 4, and Mumbai has been classified into stratum number 5. Right, and this is our sample. Now, this is a sort of data frame, and if you want to extract any variable from there, you know how to extract the information from the data frame for a given variable. And you can see here, this is the screenshot what I shown you there. Right. Now, if you try to take one more sample, so you can see here I try to repeat the same command that I want to obtain 10% sample. You can see here now I have one more sample, but this sample is entirely different than the other sample, and the interpretation of all these values, it is different. For example, again here you can see here we have obtained the sample with respect to the name of the cities. So, this is different than the sample number 1. You can see here the sample number 1 was Delhi, Delhi, Kanpur, Kanpur, and you see here it is something like this. But the cities are the same, but their IDs are now different. You can see here. Right. These are means in the first sample you have got the 7th unit, 48th unit, 11th unit, 36th unit, and so on. And in this sample you have got, say, this another units over here, 26th unit, 46th unit, 11th unit. So, this is what I meant, that it is again trying to draw the 10% cities from Delhi, 10% cities from Kanpur, 10% from Kolkata, Lucknow, as well as Mumbai. But so, these names of the city remain the same because they are the 10% of the total population, but now these are the different sampling units. Okay. So, cases here means I have just given you the screenshot of both the outcomes together, so that you can see very clearly here that here the selected IDs are this, and in the second sample the selected IDs are here like this. So, these are two different samples, right. Okay. Now, so suppose if I decide that instead of 10% I want to obtain the 20% sample, that is proportional allocation, but I want 20% of the sample, right. So, now you can see here that I am going to use here 20%, which will be indicated here 0.2, and the command remain the same here, stratified, name of the data frame, name of the variable from where we want to select the samples, and here the size 0.2. And you can see here now I have got more number of samples, and the interpretation goes exactly in the same way as we discussed earlier, right. And this is the screenshot of the same outcome. So, it is very simple and straightforward. Now, suppose I take a decision that in the earlier example we have chosen the variable capital A with respect to which we want to select the sample. Now, suppose I want to choose another variable. Suppose I choose here variable D, and from there I want to obtain 20% sample from each of the strata. Right. So, now you can see here that this is here D, and there are now 3 values corresponding to 50, which are classified into strata number 1. There are 6 values corresponding to average salary, which are classified into stratum number 2, and there are 3 values 95, which are classified in stratum number 3. And now you can see here in this case there are only 3 stratum. Why? I can show you here the way you have constructed the data frame. Here you have taken here only 3 possible values. I will use a different pen. You can see here 1, 2, and here 3. So, that is the advantage of creating a data set yourself to understand the basics. So, now since there are only 3 possible classes, total number of classes which have been reported here, you can see here they are also 1, 2 and 3. So, I hope now this will make the things more clear that how the sample has been obtained, and this is here the screenshot of the same outcome, right. Now, what I have done that I will simply saved the output of this command, so that I can use it further to show you more things, because every time if I try to execute it, then possibly it will give me a different sample and then it will be difficult for me to explain you. Suppose I execute the same command and whatever is my outcome, in which I am trying to obtain 10% of the sample with respect to the variable A, and I am whatever is my outcome, I am trying to store it in a variable, say a straight SAM, that means stratified sample, and this is the outcome which I have got here. Yeah, as I said, when I try to do it on the R console, this is going to be difficult. Now, if you want to recover the data on a particular variable from this data frame, then you know that the rule is very simple. You simply have to write down the name of the data frame and followed by the variable, and both are going to be joined by $sign. Suppose suppose I have got this data set, and suppose I want to recover that what are the cities which are selected here, right. So, you can simply use here, say means the name of the data frame, a straight SAM, and dollar the name of variable capital A, and you can see here this is the data set which has been obtained. You can see Delhi, Kanpur, Kolkata, etc., and you can see here Delhi, Kanpur, Kolkata, etc. So, this data set has been obtained there. Similarly, if you want to obtain or recover the data set on the selected cities under the variable name ID. So, I simply have to give here the name of the data frame followed by ID and joined by a variable name which is ID. So, you can see here you are getting here the outcome 19, 21, 245, etc. So, you can see here this is the same 19, 21, 245, etc. So, this data has been recovered by using this command, okay, and this is here the outcome. Okay. I have shown you that how you can use this script stratified.r to draw the sample. Now, I would try to first show you it on the R console, and then I will try to show you that how you can use the another package here, strata, to select the things. Right. So, let us come to the R console, and first I try to load the sampling package. Yes, I already have installed it on my computer. So, and now I try to copy this program stratified.r, and I simply try to here paste, and you can see here now this program is on my laptop. You can see here stratified, you can see here this is the program which I was saying, okay, right. Okay. So, now let me clear the screen and we come back to our slides, and I try to create the same data frame from where we have obtained the sample. So, you can see here this is my data frame, and you can see here this is how it will look like, right. These are here, first column is here ID, then A, B, C, D, E, and you can see here this will look like this. So, and yeah, means if since I am using here the commands like sample, etc. So, if I try to repeat this command here once again to create this another data set, now this data set will look different than the earlier one. For example, you can see here the first 3 units are here Kanpur, Mumbai, Delhi, and in the first case it was Delhi, Kanpur, Lucknow. So, that is what I said, that every time if I try to change it, I will get a different outcome. So, but now let us fix this one, and I try to draw here the samples using the command here stratified function. So, now I clear the screen and I put here this command stratified. So, you can see here you have obtained this data set, and if you try to repeat this command you will see here another stratified sample, but which is different than the first one. For example, here in the first sample the ID units are 6, 12, 16, and in other cases these are 8, 9 and 17. Right. And similarly, if you want to take here a stratified sample which is 20%, you can see here now this is another sample. And if you want to change the variable name with which you want to select the value, suppose I make it here B. So, you can see here this is my 20% sample, and if I try to make it here just 10%, you can see here this is my 10% sample. Right, because why this is happening? Because you can see here means everything is coming here 50, because B has been taken as the values 1 to 50. So, means there is no variability, right. All the values 1 to 50, that will create 50 strata. So, this is exactly what I wanted to show you, but instead if you try to obtain this sample with respect to D, then it will try to stratify it. So, you can see here if I clear this screen and instead of here D, B, I try to give it here D, then you can see here this sample is here, right. Okay. And after that, if you try to save this result as say result is equal to, or I can say here whatever is my outcome, this is saved here as a result equal to like this. So, you can see here now this is the data frame which I have fixed, and now if I want to get the information on particular variable, say here on say I want to extract the information on the variable A from this sample. So, result A, you can see here this is giving me the same cities which are mentioned over here. And similarly, if I want to have the details on the variable B from this, you can see here this is 121, 147, 101, etc. And this is the same thing which is given here under B, 121, 147, 101, etc. So, you can see here this is how you can extract the information on a particular variable also from this data set, right. So, now let me come back to our slide and we try to go for another package. So, once again we will use the same package sampling, but there is a different command using strata to draw the stratified sample. Right. So, here I have created a population. So, you can see here the population values are given in this column, and they are simply the numbers from 1, 2, 3, 4 up to here 30. And then I have intentionally divided it, actually that will be the need what we have to enter in the program in strata, that I have to first specify that how I am going to allocate my units to different stratum. So, what I have done, I have created 3 strata here, and what I am saying here, just to create more heterogeneity, that the variables, the values 1 to 6, they will be under stratum number 3, the values from 7 to here 20, they will be under stratum number 1, and the remaining values from 21 to 30, they will be under stratum number 2, and I have just given it a different color so that you can clearly see it, right. And then I will try to draw the stratified sample from this population. So, in order to create this data set, let me create here the variable pop, which is the number from 1 to 30, you can see here, and then I try to include the values here which are given in the stratum number. So, 1, 2, 3, 4, 5, 6, 3 are 6 values. Similarly, there are 1 are number in 14 and 2 is repeated 10 times. So, I create another variable here strata sam, and this comes out to be like this, and then I try to club them together in the framework of a data frame. So, I am simply creating this data which is given in the table here like this. So, you can see here now I have here sample values from 1 to 30, and then they have been allocated to stratum number 3, then 1, and then here 2, and this is here the screenshot. Now, from this population we will try to draw the sample, and for that we will use the command here, say strata. Okay, and this data population data has been stored in a variable, say data strA. So, now I will say here I will take here some example to show you how the things are going to be there. So, first you try to use the command here strata, then you have to give the name of the data frame, data strA, and then you have to give the name of the variable with which you want to stratify, and then you have to give the size of the samples which you want to draw. Suppose I have given here 354, that means I want to draw sample of size 3 from the strata number 1, whatever my first strata, and then sample of size 5 from the second strata, and sample of size 4 from the third strata, and this I want to do with respect to simple random sampling without replacement. Right, and whatever are the values which I am trying to store in this variable name str underscore sample underscore value WOR, that means stratified sample values under WOR. And when I try to execute it on the R console, I get here an outcome like this one. So, first you can see here the screenshot will look like here this, which I have modified a little bit here to explain you. So, you can see here I am trying to take here a sample of size 3, 5 and 4. So, you can see here I have got here sample of size 3, sample of size 5 and sample of size 4. And this is coming from stratum number 1, this is coming from stratum number 2, and this is coming from stratum number 3. And what are the units which I have obtained here? The units which are obtained are here given in this column. So, unit number 2, 5 and 7, they are coming from stratum number 3. So, you can see here in this table itself that unit number 2, 3, 4 etc., they are in stratum number 3. So, this is how we try to get here a sample. Now, similarly, if you want to use here simple random sampling with the replacement, so you try to use the same command, means everything remains here same, and suppose we want to draw the samples of size 4 each from each of the stratum 1, 2 and 3. So, this is what we have to change here, and then we have to change the name here SRS WR, because now we want to have sample from with the replacement. And if you try to do it here, you can see here this is the outcome. This outcome will actually look like this. This is the screenshot, and you can see here there are 4 values and 4 values here, which I have explained here. So, you can see here there are 4 values from the stratum number ID 3, 4 values from 1, 4 values from 2, and so, and this is indicating that 4 values are coming from stratum, first stratum, second stratum and third stratum, and these are the values which are selected in your sample. So, from this, if you want to recover the values of this data, you can simply use the same command, that name of the data frame, then the name of the variable and joined by the $sign, right. So, you can see here. Now, let me come back to the R console and try to show you how the things are going to work, right. So, first I have entered here the population value. You can see here this is your here pop, then this is another variable for the stratum number. You can see here it is strata SAM, yeah, this is here, and then I try to create here a data frame of these two things. So, you can see here this is my here data frame from where I would like to draw the sample. Now, I try to use the command here to draw the sample, and if I try to paste it here, you can see here if I try to see what is the outcome. So, I try to see here. This is the sample which I have got here, right. So, you can see here this is the sample of size 354 from the strata number 3, 1 and 2 respectively, which are corresponding to first strata, second strata and third strata in the last column. And similarly, if I want to have here a sample of size 4 from each of the strata, then I have to, and by SRSWR. So, I just modify my sample sizes and change method is equal to SRSWR within the double quotes. And if you try to see here, now the outcome here is like this, right. So, this is a sample from the SRSWR. So, now I have given you the demonstration that how you can draw the stratified random sample using these two different types of commands, strata and stratified.r. Now, they have their own advantages and their own limitations. Once now you have obtained the sample, then you have to write a very simple program to compute the mean or the estimate of the variances. They are extremely simple, right. As far as I know, I have not found these direct commands in these two functions, but there is a third package in which that draws the sample and also gives you the estimate of population mean and standard errors. So, that I will try to discuss in the next lecture, but that will also have its own limitations and different commands, different function, different ways of presentation. So, you take some example, try to create a population yourself and try to draw the sample and try to match that whatever you have learned in the theory, is that really happening, right. I have not given you here command how to draw the sample using the optimum allocation, because they are not really available up to now in any this function, because they require the value of capital SI, right. So, means if you want it and if you know the value of SI, you can write a simple program that is not difficult, because you have to just keep in mind that from every strata you are trying to draw the simple random sample. So, it is not difficult to write a small function yourself also if you want to really implement it. So, you try to practice, take some example, and I will see you in the next lecture. Till then, goodbye.